Namaste students, welcome to my channel Sumanth Tutorial. If you have not subscribed, please subscribe my channel. Along with that one, click on the bell icon. Along with that one, don't forget to like, comment and share. Thank you. Yes students, in this session I am going to explain you the concept of electric current, potential difference, some circuit analysis along with Ohm's law. So let us start today's session. First is the concept about electric current. So what is electricity or electric current? The flow of charges in a given time is called as electric current. In physics, electric current is represented with the letter I. I is equal to Q divided by D is the formula to find the electric current in the circuit, which says that the flow of electric charges in a given time. I is equal to Q by T. I said Q is the electric charge, so the SI unit of charge is coulomb. Nothing but in 1 coulomb of charge, how many electrons will be present? That will be equal to 6 into 10 power 18 electrons. 6 into 10 power 18 electrons will be the number of electrons present in 1 coulomb of charge. And we also know the charge of an electron is 1.6 into 10 power minus 19 coulomb. I repeat, I is equal to Q divided by T is the formula to find the electric current. And in 1 coulomb of charge, the number of electrons present will be 6 into 10 power 18 nearly. Along with that one, the charge of an electron is 1.6 into 10 power 19 coulomb. Now, the SI unit of electric current. The SI unit of electric current is ampere, represented with capital letter A. And the value of 1 ampere will be equal to 1 coulomb of charge divided by 1 second. If 1 coulomb of charge is moving in a conductor in 1 second, that will be equal to 1 ampere of the current. This is very small. To measure that one, we are having 2 more units of the current. We used to call it as sub-units. That is milliampere. 1 milliampere will be equal to 10 power minus 3 ampere. Still small. 1 microampere will be equal to 10 power minus 6 ampere. Now, let me solve one numerical based on the content. The question is like this: an electric bulb which is consuming 0.5 ampere of the current for 10 minutes. What is the charge flowing in the circuit? See here, to solve this one, first step is we need to convert minute in terms of second because the SI unit of time is second. SI unit of current is given in ampere, so obviously we need to convert the time into the SI unit. The next step, use the formula. I is equal to Q divided by T, or Q is equal to I into T. Substitute the value. 0.5 into 600, it is 300 coulomb. So the charge Q is equal to 300 coulomb. Yes students, now I am going to give you a small introduction regarding the circuit and the components, the basic components present in the circuit. So first thing is the circuit is the closed path where the electric charges will flow. That's all. Very simple definition. What is a circuit? Circuit is a closed boundary or a closed path where the charges will move. So let me draw a closed path. This is the closed path. To pass the electrical charges in this closed path, I need a source. I will use a cell, positive and the negative terminal, and the current will flow in this direction, that is I. Now I need to control this flow of charges. Means I need a switch to on and off. I will use the key. Now the electricity will pass or the charges will move in this circuit when I turn on it. But how to check? I need an indicator, right? So I will use the bulb. Clear. But I need to know what is the current which is flowing in a circuit. So I will use one device called as ammeter. So this is the basic circuit diagram. I repeat, the closed path where the electric charges will flow, that is called as the circuit. The source is the cell. From the positive terminal of the cell, the current will flow and it will come back and reaches the negative terminal. To on and off the circuit, I will use the key. When I press the key, the current will start to flow in the circuit. Then I will use a bulb as an indicator. Let me draw it. A bulb as an indicator and an ammeter to measure how much of current which is flowing in the circuit. Clear? Then let me draw few other components also which we are going to use in the circuit. So already you know it is a cell. If I join 2 or 3 or more than 3 in a circuit, that becomes a battery with the positive terminal and the negative terminal. One is a cell. The combination of the cells becomes a battery. So already you know the kick, that is the on and off state, means the dot represents on and the taking out of the dot, that becomes the off state. Now one more is the tapping switch. This is on and this is off state. So tapping switch, when you tap it, it will on. When you take out your hand, it will be off. Next is the wire. If it is like this, it is crossing over, means one wire is touching other. If the two wire it is passing and never cross, we will write like this. Next is very important, resistor. So what is resistor? Resistor is a device which has been used to control the flow of charges. That process is called as resistance. What is resistance? Resistance is a process through which the flow of electric charges can be controlled. If I want to vary the resistance in a single circuit, then I will use the device that is called as rheostat. So the symbol of a rheostat will be like this, or we can also write like this. These are all the very basic components that we are going to use in a simple electrical circuit. Now we are going to discuss the concept called as the potential difference. So what is this potential difference? The potential difference in a conductor is the work done in bringing a unit charge from one terminal to the another terminal. So from one terminal to the another terminal, we need to bring the charge. To bring the charge, how much of work we have done, that is called as the potential difference. So how we can represent potential difference? P is equal to work done divided by Q. P is equal to W by Q is the formula to find the potential difference. How much of work is done? By bringing the charge from one point to another point. And the SI unit of this potential difference is volt. Volt is the SI unit of potential difference represented with the letter V. So what is the meaning of 1 volt? If 1 joule of work is done in bringing 1 coulomb of charge from the point. So if 1 joule of work is done in bringing a unit charge from one point to another point, that value is called as 1 volt. So let us solve one numerical based on this one. So it has been very clearly asked in the question, what is the work done if the 2 coulomb of charge which will be bring from one point to another point having the potential difference about 12 volt. To solve that one, first use the formula P is equal to W by Q. So substitute the value, that is 12 is equal to W divided by 2, or W is equal to 12 into 2, nothing but W is equal to 24 joule. Now we are going to study the concept of Ohm's law. So what is this law? This law says the relationship between the voltage and the current. To study this law, I am going to use a graph. A graph of VI means the voltage across the current. So current in ampere and voltage in volts. If I plot a graph of current versus the voltage, I will get a straight line from the origin. If I find out the slope, that is V divided by I. So slope is equal to V divided by I will get a constant value. That constant value is called the resistance. So can I say by transforming this equation as V is equal to IR. This is Ohm's law. So what is the definition of the Ohm's law? The Ohm's law states that at a constant temperature, the potential difference across the ends of the resistor will be equal to the current flowing in the circuit. V is equal to IR, where V is the potential difference, SI unit is volts, I is the current, SI unit is ampere, and R is the resistance, and the SI unit of resistance is ohm. So we are having the equation R is equal to V by I. So R is the resistance and the unit of resistance is ohm and symbol is this one. So what is the value of 1 ohm? The value of 1 ohm is 1 volt divided by 1 ampere. If 1 volt of potential difference across the resistors of current 1 ampere, that value will be 1 ohm. if 1 ampere of current is flowing in a conductor having the potential difference of 1 volt, that value of resistance will be 1 ohm. Now I will say what are the factors on which the resistance of a conductor depends. First thing, this resistor or the resistance directly depends on the length of the conductor. Means if the length increases, the resistance of the conductor will also increase. Second one, this resistance is inversely proportional to the area of cross section. Means it is very clear from the equation that as the area increases, the resistance decreases. And the third one is the material in which the conductor it has been manufactured. So first let me take these two equations. So call it as equation 1 and equation 2. When you compare equation 1 and 2, we can get one equation, that is R proportional to L by A. Now I need to replace this proportionality sign with the equal sign, and you know the procedure. If I want to replace this proportionality sign with the equal sign, then I need to multiply it by a constant. Then R is equal to rho L by A, and this rho is called as the proportionality constant, and the name is given as resistivity. The name is resistivity, and the unit of this resistivity is ohm meter. I repeat, this is called as rho, the proportionality constant. Another name is the resistivity, and the unit of resistivity is ohm meter. Now let us solve few numericals based on the content which we have discussed. Here we are having two different questions. In a two different question they have asked us to find the current. So we need to find the value of current. The potential difference across the conductor they had given 220 volts, but the resistance is varying. On both the cases we need to find what is the current which is flowing in the circuit. So let us use the formula. We know V is equal to IR, or I is equal to V divided by R. Substitute the value. V is 220 volts and the resistance is 1200. Cancel the 0. So it is 0.18 ampere. So this is for the first one. Now go for the second one. Same formula. I is equal to V divided by R. So I will use here R1 so that there will be no confusion. So 220 divided by 100. Cancel 0. So 2.2 ampere. See here, observe those two numerical. It is very clear that if the resistance value is increasing, the current flowing in the circuit will decrease. Resistance less, current will be more. If the resistance is more, current will be less. Now observe the numerical what is present on the board. So it is very clear that if the resistance value is more, 1200, current will be less. If the resistance value is less, then current will be more. Yes students, let us study about the combination of resistors. So there is a chance where we need to use more than one resistors in a same circuit. Then how we can arrange? There are two types of combination. One is series, second one is parallel. Now I am going to explain what will be the total resistance in the circuit when it has been connected in series as well as in parallel. Yeah, you can see the difference. The first diagram is representing the series combination. Second one is representing the parallel combination of the resistance. Yeah, students, if the resistors are connected in series, the total resistance in the circuit will be equal to the sum of resistors value. For example, imagine there is a 3 resistors connected in series. So R1, R2 and R3. The total resistance in series will be equal to R1 plus R2 plus R3. For example, if R1 is 2 ohm, R2 is 3 ohm and R3 is 4 ohm, then the total resistance in the circuit when it is connected in series will be equal to 2 plus 3 plus 4 is equal to 9 ohm. Now in parallel, how the total resistance can be taken in parallel I will show. First let me draw resistance connected in parallel. Yeah, so let me mark R1, R2, R3. So the total resistance when it is connected in parallel will be written like this. 1 divided by Rp will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. Imagine the resistance R1 is 1 ohm, R2 is 2 ohm and R3 is 3 ohm. Then the total resistance in this circuit when it is connected in parallel will be 1 by 1 plus 1 by 2 plus 1 by 3. So the LCM is 6. 6 plus 3 plus 2, that is 11 by 6, 1 by Rp, or Rp will be equal to 6 divided by 11 ohm. By observing these examples, it is very clear that when the resistance are connected in series, the total resistance in the circuit will be more compared to that of the resistance which is connected in parallel. So the total resistance in a circuit when it is connected in series is more than the total resistance in the circuit when it is connected in parallel. If only 2 resistors are connected in parallel, then there is a shortcut for you to find out the total resistance when 2 resistors are connected in parallel will be R1 R2 divided by R1 plus R2. Very simple formula. For example, if R1 is equal to 2 ohm and R2 is equal to 3 ohm, then Rp, that is the total resistance connected in parallel, will be equal to 2 into 3 divided by 2 plus 3, that equals 6 divided by 5 ohm. So this is applicable if only 2 resistors are connected, that is in parallel. Yeah, students, in a 2019, a question it has been asked like this. There is a circuit. In that, there is a 20 ohm resistance of lamp is there, and the conductor is having the 4 ohm. It is that has been connected like this. I am showing you like this. I didn't say it is series or parallel. That's you need to decide it. Then they have telling it has been connected with the power source of 6 volt. What is the total resistance and what is the total current flowing in the circuit? See here, by looking at this diagram, it is very clear that the resistance are connected in series. So the total resistance connected in series will be equal to the sum of the resistance, that is 4 plus 20, it is equal to 24 ohm. So that is the total resistance connected in a circuit. Now we need to find the total current, that is I is equal to V divided by R. Substitute the value. 6 divided by, don't use 4 or 20, you are going to use 24. So it will be equal to 1 divided by 4, 0.25, and the unit is A, that is ampere.